Hello, fine people. Today is Friday, 9/18, so you'll be watching it this evening, or the 19th, which is Saturday, or the 20th, sometime in one of those days. Our topic for tonight is quadrant angles. A quadrant angle is an angle that is right in between two quadrants. So we call it a quadrant angle. So what angle is there between the first and the fourth quadrant? It's the angle that sits right on this line, and that angle is 0 degrees. We can also think of it as 360, and most commonly we think of it as 0 or 360. Because you can't tell if this is the angle whether we went all the way around or not. So let's just give it these two options. The second quadrant angle is between the first and the second quadrant, and it looks like this. It's hard to draw an angle where there's no triangle possible, but at that point it's a 90-degree angle, and here we have 180, and here, and that's between the second and third, and then we have 270. So those are called the quadrangles. 270 is between the third and the fourth. So if you try to draw a triangle at those spots, like if it was a 45, we could draw a triangle. But you'll notice that these quadrant angles, that's not possible. So let's go ahead and see what their sine, cosine, and tangent are. In order to do that, I'll bring out our new friend, the unit circle, which reminds me of your assignment. You have a handout to fill in, and that is the unit circle. Trying as best you can to come up the radians and the coordinates around it in sixths and in fourths without looking back. So it's a training ground. And when I have the unit circle, it turns out it's the unit circle's coordinates right here. Since this is 0, 0, this would be 1 over and 0 up. So 1, 0 is the name of that coordinate. And this coordinate is 0, 1. Because from the origin, we do not go left or right at all, we just go up. So the first coordinate tells me the left or right, and the second one tells me the up and down. Here then, we start here and go back, but not up and down, so we have a negative 1, 0, and down here we have a 0, minus 1. Alright, with those from our training today, the 1-2 punch, 1, 2, 3, well, the first coordinate is always the cosine, and the second coordinate is always the sine. And that happens even at the quadrant angles. So we're going to make a little chart. Let's see if I can fit it on, I guess, underneath of this. So say I have all my quadrant angles, 0, 90, 180, 270, we'll put in 360, but it's the same as 0, so we'll get the same results there. And I'm going to list the sine, cosine, and tangent for these quadrant angles. So just kind of make a chart. And I'd like you to be able to come up with this chart just visualizing the unit circle. So let's see if we can do that without looking at the unit circle. This is second coordinate at 0. So I recall at 0 degrees, the coordinate is 1, 0, so the second coordinate is 0. So let's check back, see if that was right. It does hold. And we can see the cosine is the first, and tangent was, cosine is 1. The tangent is going to be the second coordinate divided by the first. So this one divided by this one. 0 divided by 1 is 0. We can have 0 on the top, but not on the bottom. We cannot divide by 0, but we can have 0 divided by 1. That's fine. All right, 90, without looking at the unit circle, what would be the second coordinate, the sine of 90 degrees? Monkey math, when we go up from the origin, we're at 0, 1. So the second coordinate is 1, the first is 0. But look what happens for tangent. This divided by that, it creates an undefined term. We cannot divide by 0, so we get an undefined term. Let's go and see, check that. Yep, 0, 1. The 180, thinking of its position, its coordinate on the unit circle, 180 is negative 1 over and 0 up and down. So negative 1, 0. So the sine is going to be the second coordinate, cosine the first, and the second divided by the first is 0 divided by minus 1, which is fine. That's just 0. 270, that one's peeking at us, so negative 1 is the second coordinate, so I put that in for the sine. Cosine is 0. Can we get a tangent at 270? No. Again, we were dividing by 0. No way. 360 is going to be the same as 0. And we had the point 1, 0, which gives us 1, 0, 0. Oops, no it doesn't. 1, 0. The second coordinate is 0. The first coordinate is 1. And the 0 divided by 1 is fine. It's 0. All right. So that's it, all the values of the quadrant angles. And now we'll finish with another kind of loose end and trig. We're going to give ourselves the 4 coordinates, the coordinate plane again, and I'm going to look at any angle in the first coordinate quadrant. So here we have a typical angle in the first quadrant. When we have that, you'll notice side adjacent is positive. It goes from here to here, and side opposite, if we're talking about this angle, which we are, is positive, and hypotenuse is always a positive value because it is a distance from 0. So a distance, even if you're going downward, is going to be 0. Hypotenuses, I need the plural of that if anyone has it. The hypotenuses are always positive. Doesn't sound right. So with those marked, I can indicate that the sine in the first quadrant, sine of any angle is going to be a positive number divided by a positive number. Opposite over hypotenuse is going to be positive. And cosine adjacent over hypotenuse will also positive over positive is positive. And tangent is opposite over adjacent, positive over positive. So in the first quadrant, all of those trig functions are positive. Now, let's draw a typical triangle in the second quadrant. So there's the angle right there. Things are changing. Here, side adjacent went backwards, so it's negative, but side opposite went up, so it's positive. And a hypotenuse is always positive because it's a distance from here to here. All right, so sine in the second quadrant, sine of theta is opposite over hypotenuse, positive. And cosine, however, is a negative. Adjacent over hypotenuse is negative. And tangent is opposite over adjacent. This time, another negative shows up. All right, let's see if I can gather those results a little clearer because they're kind of interfering with the signs on my triangle. So we found out that sine was positive, cosine was negative, and tangent was negative. So I'll just group them better there. All right, now what happens in the third? See if you can do that one. I will do it silently. Did you get these results? The sine was opposite negative over positive hypotenuse. And again, even though the hypotenuse looks like it's going downward in some fashion, we define the hypotenuse as a distance from 0, 0, so that is a positive value. Sine, however, went down, and then negative over positive, as did cosine. And look what happens to tangent. Opposite is negative, divided by adjacent, which is also negative, creating a positive. All right, one more. And we have this beautiful bow tie. We're ready to go out to a formal. So we have positive on this, negative on this, and hypotenuse is always positive. There's our angle theta. So working without my voice again, fill in sine, cosine, and tangent. What happens in quadrant 4? All right, hopefully you got those results. So I'll put them all in a little box. There we go. So sine is opposite over hypotenuse, a negative. Cosine is adjacent over hypotenuse, both positive. And tangent, opposite over adjacent, we have a negative. All right, there is a little word that will help you remember that, and I didn't make it up all, and even though it's not all true, we can still use it. All students take calculus. And that's a common phrase used when this is taught in many textbooks and by many teachers. And it says all students take calculus. That means in the first quadrant, all of the trig functions are positive. In the second quadrant, sine is positive. S for sine. In the third quadrant, tangent is positive. Take. And lastly, in the fourth quadrant, cosine. So how cool is that? Well, another cool thing is that we are done for this evening. So I hope you're having a good weekend, and you get this down in your comp book, and I'll give a check on that Monday morning. See you then. Bye.